In this experiment, we're going to be looking at what is called edible tectonics, and we're looking at different types of plate boundaries and what types of movement are associated with those, along with different types of stresses. So we'll need a paper towel. We'll use a Milky Way bar to represent our model of the Earth. We'll also use a plastic knife. So to begin this, the students are going to open up their candy bars, place them on their paper towels, and then we're going to create our tectonic plates at the surface by first taking our thumbs and just crushing the top of that to generate those different plates. So go ahead and do that now. So we've generated our tectonic plates here at the surface. Now we're going to look at the three different forces and the different types of boundaries that are associated with this plate motion that we have. So the first thing we're going to do is we're going to take both ends of our candy bar and we're going to pull those ends of the candy bar slightly apart so we can see inside. What type of forces did we use when we're pulling those apart, Lauren?
Tension?
Yes, we have a tensional force where we're stretching that crust. And what type of plate boundary would you associate with that tensional force that we applied to our candy bar?
Divergent?
That would be a divergent type boundary. Now let's take those candy bars and let's squeeze them together and smash them up a little bit. We're going to see some different features show up here because some of the chocolate gets forced upwards. And what kind of features did we just form when we're pushing that chocolate upwards, Isaac?
Mountains.
Yeah, it could be mountain ranges, and where some of the chocolate gets pushed back down into the earth, that would be what type of feature that we'd see there?
Like trenches.
Trenches, and also we'd know where we have trenches is what type of zone.
Subduction.
That would be a subduction zone, good. So the type of force that we use there where we took this candy bar and we pushed it together is what type of force then?
Compressional.
And the last type of boundary that we have to deal with here is the type of motion where these plates are going to be moving back and forth relative to one another, sliding past. Let's take that candy bar and let's tear it all the way apart, and then we're going to slide that candy bar back and forth relative to one another. And then when we see that happening, we don't see anything being created or destroyed at that area, but the plates are just sliding past one another. What type of force, Isaac, are we using there?
Shearing?
Yeah, we have a shearing type force, which is associated with which type of boundary?
Transform?
That would be a transform boundary along those lines. And then the last thing we're going to do here is we're going to go ahead and take that knife and at one of the ends, go ahead and try and cut that candy bar straight through down to the bottom. So we have the earth, the three layers of the earth here represented by the nougat, the caramel, and the chocolate, where the chocolate would represent which part of the earth?
The lithosphere?
The Earth's lithosphere. So that's our crust and our upper mantle that represents that. So that's our tectonic plates. And that tectonic plates are resting on top of that caramel layer that's kind of fluidy and can flow a little bit, which would represent which part of the Earth?
The asthenosphere.
Yes, that would represent the asthenosphere. So the nougat part that's underneath that caramel would represent which layer of the Earth?
The lower mantle.
That would be the lower mantle. So we have a solid material, then we have our semi-solid that flows in the asthenosphere, that caramel. And then we have our firm, rigid outer portion of the Earth, which represents our lithosphere, our tectonic plates up there at the surface. Included with this activity in your workbook is a reflection here, which is going to go through each of the associated stresses, the relative plate motion, and the different types of geologic formations that we would see at each of those boundaries that are associated with those different types of plate motion that we just looked at within the candy bar. The motion of the tectonic plates is caused by the convection that's taking place within the asthenosphere. That convection is driven primarily by leftover heat from the early formation of early Earth, as well as radioactive decay of materials within the inner core that are working their way out towards the surface. It is that convection, along with gravity, that is driving the plate motion here at the surface that gives us different features that show up, such as volcanoes, mountain ranges, deep ocean trenches, subduction zones, mid-ocean ridges. We see things like volcanic eruptions along with earthquakes along those boundaries that allow us to identify where the different boundaries exist on the Earth.